Now let's take a look at a product and quotient of two complex numbers. So z1 is r1 cosine theta 1 plus I sine of theta 1, and z2 is r2 cosine theta 2 plus I sine theta 2, and those are complex numbers. So when you find the product, what we're trying to do, or what we're doing, is you just multiply the radii, r and r, together, and then you add the cosine thetas together, plus the I sine of thetas together, and then that will get your product. When we're dividing, you divide the R1 and R2, and then you subtract the thetas. So let's multiply complex numbers first. Find the product of z1, z2 of z1 equals 3 cosine of pi over 4 plus I sine of pi over 4, and z2 equals 2 cosine of 3 pi over 4 plus I sine of 3 pi over 4. So what we will do is we will write that we're going to multiply first the r's. So this is going to be 3 times 2, and then we will do the cosines together. So this is cosine. You subtract the thetas, pi over, or you add the thetas, sorry, when we're multiplying. Pi over 4 and 3 pi over 4. So hopefully remembering like our vectors here. Then I sine of pi over 4 plus 3 pi over 4. So then this becomes 6 times cosine of 4 pi over 4 plus I sine of 4 pi over 4. 4 pi over 4, though, is just 1, so this is cosine of pi plus I sine of pi. Then we evaluate that. What is cosine of pi? Cosine of pi is -1 plus I sine of pi is 0. So therefore, this becomes -6. So try this example. Find the product of z1, z2 of these two trig forms here. Hey, trying this out, you should have gotten 10. So adding, multiplying the radii together, 2 times 5 is 10, and then 5 pi over 6 plus 7 pi over 6, that's 12 pi over 6, which simplifies to 2 pi, and then evaluating those angles. So this is just more practice in multiplying, and so let's try this, very similar. So this is going to be 2 times 8, and then cosine of 2 pi over 3 plus 11 pi over 6 plus I sine of 2 pi over 3 plus 11 pi over 6. So here we have to get a common denominator, so a little bit more work. So I'm going to multiply this by 2 over 2. So then that'll become 4 pi over 6. And then so that'll help me in multiplying these. So 8 times 2 is 16. This is cosine of 4 pi over 6 plus 11 pi over 6, which is 15 pi over 6 for now, plus I sine of 15 pi over 6. Now let's simplify 15 pi over 6. What is 15 pi over 6? 15 pi over 6 we can reduce to 5 pi over 2, and then let's reduce that more to our single unit circle. So 5 pi over 2, we can take out a 4 pi over 2, which is 2 pi, and that will make it a pi over 2. So we can change this cosine of 15 pi over 6 to just a pi over 2, and then evaluate from there. So cosine of pi over 2, that is 0, plus I sine of pi over 2, that is a positive 1. And there's an I there. So therefore, this answer ends up being 16i. So try this example. Find the product of these here. So trying this out, you actually end up getting pi over 2 again, but the answer is 12i. Let's divide complex numbers now. So it's very similar to what we did before. So now we're just going to divide the radii, 24 and 8, and then instead of adding, we're going to subtract our, in this case, our degrees now. So let's divide 24 over 8, and then this is going to be cosine of 300 degrees minus 75 degrees, and then I sine of, plus I sine of 300 degrees minus 75 degrees. So this becomes 24 divided by 8 is 3. And then cosine of 225 degrees plus I sine of 225 degrees. So now we have to evaluate the angle. Cosine of 225 degrees is here. So it's 225 minus 180. So that is 45 degrees. So I know this is a pi over 2, but this is 3 pi over 2. Well, I think about that. And then knowing that it's that angle, it should really just be negative root 2 over 2 and negative root 2 over 2. So this is 3 times negative root 2 over 2 plus I root 2 over 2. And then we could simplify. So this is negative 3 root 2 over 2 plus 3 root 2 over 2I. So try this example here. Find the quotient of these here. Okay, that one should be pretty fast. So this ends up being root 3 over 2 plus 1/2I.